So good morning, good afternoon, good evening, and welcome to the Math Matters webinar. So as Rochelle mentioned, my name is Karishma Panwani. I'm the Director of Academic Product Management here at Maplesoft, and I'm excited to present this webinar. So I want to start, with mathematics. It's played a major role in bringing many innovations to reality. Many mathematical theories and models of real-world problems have helped scientists and engineers grapple with seemingly impossible tasks. This is something we know. And mathematics, it continues to shape our society, and its impact on our daily lives has no bounds. When a student succeeds at math, not only do they thrive personally through better academic and career options, their success also benefits society because some of those students will go on to accomplish things that will change the world for the better. At Maplesoft, we are passionate about math and math education, and our goal with the Maplesoft Mathematics Suite is to provide educators with software tools that will make it easier for them to meet their students where they are and to help their students understand and succeed in their math and math-based courses. Math matters. Now, the Maplesoft Mathematics Suite helps educators in a number of different ways. It allows them to engage students who are easily bored or distracted. I was one of them. To motivate students who don't see the point, why am I learning this? To overcome math anxiety. To instill true understanding in students who are just going through the motions. To provide sufficient opportunities for practice, to allow educators to evaluate progress in a world where it's so easy to just look up the answer, and to deal with varying levels of readiness for the course material. So let's kick this webinar off. And I'm going to share this quote. And it was from one of the educators. We work with lots of educators. We're always getting feedback, trying to make sure that we understand, what are the challenges that educators face. And one that really stood out is, I find it hard to keep my students engaged in math. They say it's boring or too hard. And I hear that as well from the students that I tutor and from my son. So the Maplesoft Mathematics Suite can make math come to life. It makes math touchable, visual, and our tools can show students that math doesn't have to be scary. On the contrary, it can inspire them and get them excited about the possibilities. And so now I'm going to show you a few examples. Give me 1 second. I have a video and it popped up on the wrong screen. Here we go. Let me start that from the beginning. So right now, this first example, it's from our web-based tool. And it's just an example about exploring geometric transformations. I'm going to pause it here just to point out a few features of these documents. So one of the things that we want to do is make the mathematics come to life. We want to allow students to explore with a concept, to play with it, to see what happens as they move a slider, as they drag or change the shape of their, in this case, their particular polygon. So you'll see over here, that's what we're doing over here. Now, this particular example is on geometric transformation. We also want to be able to create these documents that include text and math and explanation so that a student understands what they're seeing. So this is another example over here. So on rotation, now I'll show you one with dilation. Student is going ahead and just moving those points on the screen, and then they can change the value of B. In this next example that I'll show you, it's solids of revolution. So this is something that, a concept that I know a lot of students have difficulty conceptualizing. And this is an area where we get a lot of requests from instructors. And I love this example because it gives you the ability to see the math, see the formula. In this case, the total volume is defined by the summation. Calculate the volume over here. But then what you'll see momentarily is that it allows a student to go ahead and move that slider. And every time they do that, and then they go ahead and click Update Cylinder, the solid changes. And you'll see that the plot is changing over here. Now, this example was structured, so there's definitions to the right, and there's also the 3D plot. Again, giving a student the ability to play with the mathematics. In this example, I wanted to show you Riemann sums. So here we're going to load a tutor that we have in Maple. So first we're going to load, Maple comes with student packages. There we go. So one of the things we're going to do is we're going to drag this equation in. Again, the idea here is we want students to explore and play with the math, not have to worry about commands or syntax. So in this case over here, they use the context panel. They're able to get the solution. They can go ahead and call the tutor, and that'll pop up on my screen momentarily. And now they can change the A and B values, so the endpoints. And you'll see when I click display, the plot will update. They can, of course, animate this and start understanding what does it mean, or how does the area change as you increase the number of partitions. So these are just a few examples of how the Maplesoft Mathematics Suite can help, make math come to life, make math come to life, I should say, and how we can improve engagement. I'm sure you've all had variations of this quote. So my students don't understand why they should learn all this stuff. They ask, what is it good for? When will I ever need this again? So it's critical, and we hear this often from educators. We want to provide motivation. So we all know that math matters, but how do we get students to buy into that statement? How do we get them to realize that math powers the modern world? And it's easy. It's through real world examples that show them that math is everywhere. But putting together these examples can be extremely time consuming. So one of the things that we've done in the Mathematics Suite is provide you with content, and this content has these real world examples that you can use as a starting point to explain and motivate different concepts. And I'm going to show you a few of my favorite real world examples. So I'm going to start off with this 4-color theorem exploration. Let me pause this over here. So this is a problem from graph theory, but what I find so interesting about this is not only that it's visual and a student can play with it, but the history behind this. And this is a way to kind of, again, bring math to life like I talked about before, but also to provide motivation. So this idea it came to life in 1852. And it was when Guthrie asked the question, is it possible to color any map with 4 or fewer colors so that the adjacent regions are colored differently? And I would never have even thought about this. And so you go on and you see, I'm trying this myself. So I took a video of me playing with this. I'm changing the colors and I'm seeing if I can actually do this with 4 different colors. And I really like this example because it illustrates that math is hidden in all types of real world applications. Another really notable feature about this particular example, it was the first major theorem to be proved using a computer. And so here you see no mistakes so far until I click right now, and I didn't get it. But of course I can click on reveal answer and I can see what the solution would look like. And I can try again, endless hours of fun. This next example over here, this one comes from the signal processing world. And again, part of the reason we want students to learn this math is to be able to solve these real world problems. So in this application, it's speeding by very quickly. Let me pause that. So in this application, if we go back a little bit, what we're doing over here is we're kind of exploring the concept of a finite impulse response and designing an FIR filter. And so here we have, an area, and we allow, if you see this over here, a student can actually import an audio file into this particular document. And so they can work with real data. Now we keep going over here, and now we actually build our filter. And so a student can choose, do we want a low pass filter, high pass filter, band pass, band stop? The math will come later. The idea is, do you understand the concept? Why do you need to learn these concepts? So what do I pick in this video? I think I pick a high pass. So we can have a plot of this over here. This is what it looks like. And now we can actually go ahead and filter the signal. So we have dials over here, making it very interactive. We can go and change the signal or the subsection of the signal that we want to filter. We can then execute our filter, and you can play the input and output. Next example over here is one in which we want to use mathematics to determine the position of a gunshot through acoustic localization. Ooh, speeding by again. Let me go back and pause this. So over here, this is what we want to do. And in this particular application, what we want to do is use two methods to determine the position of the gunshot. So we want to use the method of minimization of the least square errors for these equations 1, 2, and 3, as denoted here. And we also want to solve this using numerical solutions. And so this example that was created then goes on and talks about or explains the theory. So we have the parameters, we have the math for the analysis, and now we can actually easily create some visualizations over here. So I'm going to generate a plot, and then I can go ahead, and if I want to, I can start hiding some of the plot commands. So if I want to clean up my document, polish it up, and just really make sure that the students are focusing on the concept that they need to know, I can do that. Again, just making the math come to life, providing them with motivation, trying not to get them too overwhelmed too quickly. Speaking of getting, not wanting students to become too overwhelmed, another challenge that I know instructors face is that, students are dealing with math anxiety, and they are the ones trying to combat this. And one of the quotes here, again, I took from a conversation with an instructor. She said, "So many of my students think math is scary. They arrive in my class already stressed out and anxious." And we know that if a student is going into class with that mind frame, they'll never be able to learn. And so one of the ways that we help educators through the mathematics suite combat math anxiety is we make it easy for them to check answers, to generate practice problems, to work with concepts at a higher level, and to actually allow students to self-evaluate, show them where they made a mistake. Let me play this video. So in this document, what I want to show you, I'm going to pause it here, is we're asking a student a question. Go ahead and evaluate the following integral. And this is really nice. The student can work on this, online on their own time, when they're maybe not so anxious, and just work through solving this problem. So this is the question. Now, one of the things we know is that students will always continue to work with paper and pencil. And so we want to support this. So now you can use the Maple calculator. And so the Maple calculator is going ahead and taking a picture of the student's work. So a student could do it on paper and pencil, take a picture of their work. Now the Maple calculator works with a single expression, but as long as you're signed in with the same credentials, you can click into Maple Learn and pull up your handwritten solution. And then notice here, this option. The option over here appears to check my work. And this is something I'm really excited about, because a student can click on this and Maple Learn will go through line by line and check where they might have made a mistake and actually indicate the line that generated the mistake. This gives students the confidence to, work on something by themselves. In this case, they can fix the mistake. If they have trouble, if they don't understand why they made the mistake, they can go ahead and ask their peers, their tutors, or their instructor. Another example that I want to show you over here is one of the tutors. And so you can see Maple comes with many different tutors, but this is for differentiation methods. So over here, the student can go ahead and get a hint on solving a problem. They can apply a rule. So if they go ahead and now apply the wrong rule, they get feedback and it says you can't apply this, and it gives them a hint. Then the student can continue to solve this, again, line by line. Now, this is an application that allows them to work through this over here, so they can pick the solution and then they can see the answer. Of course, if they click all steps, it's all documented into this notebook. So I'm going to show you another tool, our tutor, I should say, in Maple. One is for integration methods. Same concept. Over here, a student could go ahead and change this function. So any function they want, anything that you've given them in the practice sheet, anything that they're maybe in the textbook, they can go and change this. This one is, they're going to go ahead and enter in a lower endpoint and an upper endpoint. Click start. And now you'll see you can, again, work on the problem. The ability to get a hint is there. If the student is stuck, they can ask for the next step, just giving them one more step to solve this problem, or all steps. So that's another way that we have tools to combat math anxiety. Those are just two examples, and I'll show you more in other videos. So I was recently at a talk in North America. It was the American Mathematical Society, AMATIC, sorry. I was at their conference, and one of the things that resonated with all of the instructors is summarized by this quote: "My students just go through the motions. They mimic what they saw in class and get the right answer, but don't really understand what they're doing and why." So one of the things that we want to do is provide educators with solutions that allows you to help students visualize concepts, break problems into steps, and use scaffolding methods to build on existing knowledge. And this way you can drive deeper insight and understanding. So let me show you a few examples over here. I've taken this one, it's on areas of basic geometric shapes. So one thing though I want to show over here, and let's maybe slow this down a little bit, is that it shows, how do we derive some of these formulas? And there's something interactive over here. It, helps the student understand and not just memorize the formula. It allows them to break it down. So over here, this is the area for a right trapezoid, for a general trapezoid. And again, you can move the slider, I should say, and it explains where the formula came from. Same thing for a parallelogram. And then the rhombus. In this next example over here, this is again looking at the interior and exterior of angles. And all of this content is available within the Maplesoft Mathematics Suite. So these are just two that I picked out. But again, here you have a slider to animate this proof. We want students to understand, why the proof exists as it does. Why does the equation of the exterior angles of a triangle equal 360? And so one of the things you do over here is explain that. Completing the squares. So I learned how to complete the square algebraically, and I memorized the formula, and as long as I knew the formula, I could always complete the squares. It was only recently in a conversation with an instructor was I introduced to the world of algebra tiles. And I love this because this example, even at my age, I'm learning something new all the time. It helped me understand the mathematics of why I was, performing the steps I was performing. So really simple over here. Again, the tools are interactive, they're visual, and a student can go ahead and play with this and hopefully motivate and allow them to understand why they're doing what they're doing. So over here, I think I need to drag one more. And then those are 3, and I'm going to add 1, and then of course subtract 1. And so now I can go ahead and formulate my response. I didn't have to use the algorithm that I was taught. Click on this. Now, of course, at any point, I can go ahead and I can verify my result with the tools. So I'll click on this. I can say, okay, give me the solution. And I can also verify this through the plot. Last one. Well, I'm going to slow this down a little bit. So one of the concepts that I struggled as an engineering student was my first differential equations course. And I think, again, this was an area where, I could follow the instructions, I could follow how to solve the problem, but I don't think I really appreciated what the solution meant. And so here are some documents. It's a series of documents. So here, you can actually put a collection of documents together that a student can work through. And this particular one introduces the concept of a differential equation and how we can have multiple solutions. All of this text is a starting point, so you can change it or modify it. And then we scaffold. So we build on top of this. Maybe now we start looking at, well, what is the solution, a solution to a differential equation? What is the solution when you have initial conditions, and looking at the concept of a particular solution. So again, over here we have that. Now we can start getting into the algorithms and the methods for solving problems. So here there's a document on separable differential equations, and it shows you step-by-step procedure. And lastly, there is always, going back to this idea of giving students the ability to practice, make sure that they understand the concept, is a document for solving differential equations. So a student could do this by paper and pencil, and then compare whether their result is the same as the one over here. They could also use that check my work that I showed you earlier to verify and see any mistakes that they may have made. So moving on to practice. I love this quote. It was actually told to us by a chair in a math department. Math is not a spectator sport. My students won't learn just by watching me do problems on the whiteboard. They need to practice, but textbook problems are limited in number and encourage cheating. When students get stuck, they can just look up the answer. And so one of the things that we want to do is provide students and educators with an inexhaustible pool of practice problems. And then students can practice this on their own, using the tools to help them when they get stuck. I showed it to you before, to be able to see where they went wrong and maybe get back onto the right track. And so these are something that all of the tools within our mathematics suite do. So this is an example, a skills practice example. So this document, similar and feeling, has a hint. And now a student could go ahead, and in this case, what I did right now, just to show you, is again, use the Maple calculator to upload a picture of their work, or I should say, upload a snapshot of their handwritten work. Comes in, and now they can go and check their work. So if they made a mistake, they're able to look at this. It identifies the line in which they made a mistake. They can go ahead and correct that. Click on check my work again. They can go ahead and ask for another question. Again, get a hint. These hints can be changed, or they can click on show solution. And it has the solution for them. Now, this document has the solution. We wanted students to be able to kind of understand the steps if they got stuck. You can easily change that though. And so as I'm clicking next, you'll see that there are different problems that students can work on. This next example, again, it's a variation of the last, but this one over here has multiple questions on the same sheet, and it allows students to check their answers, or in this case, reveal the results. So you can format questions and practice sheets any way that you want. This one is a word problem. And so here, a student can go ahead and use the entire document canvas, solve their problem. So I'm doing the first one over here, A. They're working on that. And then they can type in their answer and check. So in this case, I'm just going to show you the solution, but all of the solution is here. Here's another example of it. So this one is expected value. So all of these different solutions can be deployed in different ways in different products. So that when you saw one for step-by-step for calculating expected value, you can have steps, you can remove steps. Here's another one with integration. So the student can work through these math entry boxes, or they can go ahead and when they have the answer, type in the answer. So they can go ahead and do this. And then click check answer, and they'll provide them with feedback. In this case, it's telling them to go ahead and add that constant of integration. And then they can get another question. So those are just a few different examples of how our applications of providing practice. You can do it for factoring. I showed differential equations, linear algebra. Again, the technology is there to support you, and it's just about you deciding what you want your students to do and how you want them to learn the material. So another challenge and where we want to support educators is I'm finding it hard to measure my students' progress. It's easy for them to cheat on homework with all the online resources available now. And so what we want to do then is, this is a given. There is tons of online resources available to students. So now the task and what educators are trying to do is, start asking conceptual questions, giving project-based assignments to find other ways to make sure that students are understanding the information that they are learning. And so what I showed you before is just kind of providing practice on, solving a problem and the mechanics of solving the problem. But there's other ways that we can evaluate a student's progress and making sure that they're learning the material. So I like this example. This is a high school example, but it's that famous question of, which option would you choose if you won a lottery? Would you choose the option when you're offered 1 cent on the first day of the month with the promise that your money will double every subsequent day after the first month? Or would you take the option which just gives you a fixed amount right away without doubling? And you'll be surprised, having tutored some high school students, how many students get stumped by this. So over here, there's a table, and a student can go ahead and start, calculating the amount of money on day 1. So day 1, they get 1 cent. And then you'll see day 2. Now, so for the calculations are easy. And then you'll see kind of by day 5, it starts, or day 10, I should say, it starts adding up. But the reason I showed you this is not so much the table. What I often find is that students can go ahead and they can, just double each subsequent value. What I find interesting over here, and I'm going to speed this video up to show you, is this next problem. So a lot of times a student is able to complete this table, and then you ask the question, okay, how can you represent the doubling that we see in terms of an exponent? And that's where a lot of students get stumped. So they were able to calculate the results, but they're not able to break it down into, what actions are they performing and how do you represent as the exponent? Often if you give students problems to solve or work on with exponents, they can do that. But it's actually setting up that initial equation that causes the most anxiety, that they don't know how to do. And this is an opportunity to provide students with, these type of fun applications that allows them to say, okay, well, how do we represent this? And so in this case, I know the answer, so I was able to put it in. But there's areas to allow a student to explain the concept, think of other methods. So that's just one example of a document. And I'll show you another one over here. This one comes to us from a calculus teacher at a high school. And so one of the things that she often asks her students to do is to brainstorm piecewise functions whose solids of revolution resemble drinking glasses, such as cups and wine glasses or vases. And so this is this document over here. Again, it's about making sure a student understands the concept and giving you the ability to evaluate that understanding through these types of projects. So here's one, and we've gone ahead and changed that goblet. And I think I have one more that I wanted to show you. I actually had quite a lot of fun playing with this document. And here's another one. Fun project that also gives you insight into how a student is doing. And of course, now they can use the contact panel to evaluate the integral. And there we have it. And this last example that I wanted to show is the birthday paradox, the statistics example. So again, I really like this example because it allows a student to work on this, kind of have a project or work independently. It's not about, just following the math or setting up an equation and solving it. It's about making sure that they understand the concept. So this is a math app. You'll see that there's the main concept written over there. There's this interactive component. Students can play with it over here, so they can run these simulations, and at any point they can go ahead and get an explanation of the probability. And the last one, students entering my class have vastly different backgrounds and knowledge in math. I want to help all of them get better and develop a deep appreciation for math, but time is scarce. And I know this is a challenge, and all of the different educators we talk to, the department chairs that we talk to, this is a challenge, right? Like, we want to support our students, we want them to succeed, but there's only a finite amount of time. And so one of the things that we do is we provide educators with content, lots of content that allows them to gauge a student understanding. So there is no need to build your own content from scratch. And I'll show you some of this. So over here, this is in Maple. Some of the content that we have is, I'll show you, right within the product, there are study guides. There are study guides in this case for pre-calculus, calculus, and multivariate calculus. There are student packages. All of these kind of break down concepts and have associated commands that you can use. We also have over here assistants that you can use, tutors, which I showed you in previous videos, and then we have lots of tutors. We have some math applications, and I've showed you a few of these as we've gone. But again, all this content is here ready for you to use it. And if you ever have any questions or difficulty customizing things, we're here to support you. So I'll just show some of the different pieces of content. So this is one of Solids Revolution. You'll see they're all set up the same way. And in this particular one, I'm going ahead and I'm changing the function, and then I can animate it as well. I'll just speed up for the sake of time over here. Oh, I went too far. The other thing is the application center. So there's a large community of educators who use all of our different products. And so if you're looking for an application, another source is the Maplesoft Application Center. Bunch of different examples that you can use and that you can pick and choose from. Over here, organized into different areas. And one of them that I want to show you is this one. This is one of my favorite ones. And of course, you can go ahead and use this. There we go. Why I needed Maple to make cream cheese frosting. Again, a fun application that brings the math to life. So over here, it explains it. It talks about the approach, deriving the cubic equation over here, and then solving the problem. Maple calculator. So one thing here, we have content, but then we also want, as I showed you, students to be able to solve their problems, work independently, get solutions. And so here I'm going to show you an example of the Maple calculator on a matrix. I'm going to enter that in, and I have options and steps. So this is a resource for students to go ahead and check what they're doing. At any point, they can take a picture of their completed work and bring it into Maple Learn. And this is another resource, tons of content over here in Maple Learn Gallery. We have over 150 pieces of content organized into different areas. Take a look. All of this was initially was created by us. And then as these products started to grow, they developed their own community. And we have high school teachers, college teachers. Tom Crawford is a professor at Oxford who creates content that you can go ahead and use as the starting point for anything that you want to do. And some of the fun things that I wanted to show you, again, kind of managing readiness, is this one that we've found a number of instructors are using in their Calculus 2 class to make sure that students have, remember the concept of differentiation and how to evaluate a derivative. So math is fun, and some of these things are not just reserved for primary school. They can be used at all different levels. And I'll skip along to see the answer. This one was done for Halloween. And here you have it. And of course, there's a try another. You can generate a new puzzle. So at Maplesoft, we believe that mathematics improves our lives and makes us safe, more efficient, and more innovative. Without mathematics, we wouldn't be where we are today. And that's why we're passionate about helping students, researchers, engineers, and scientists take advantage of the power of math to enrich the world we live in. At Maplesoft, we believe that math matters, and we're proud of having a real impact on the world around us. So we're coming to an end of this presentation, and a few things that I wanted to note. So in this presentation, I showcased the Maplesoft Mathematics Suite. And it's a set of 4 products which provides educators and students with access to the world's most powerful mathematics engine through easy-to-use interface that are designed to meet the needs of students at different phases of their education. All of these tools are built on the Maple Math engine. But as I mentioned before, they have different interfaces. And these interfaces are customized depending on what a student is learning, depending on what you, the instructor, are trying to teach, the course, and depending on the institution. So the suite includes online, desktop, and mobile solutions that cover math from high school to graduate school and beyond. And it's suitable for math courses as well as subjects that you make use of mathematics. Think engineering, physics, chemistry, business, economics. Now, the products that make up the mathematics suite and that I showcased are Maple 2023. So the newest release of our renowned desktop software will be available to users in the next few days. And Maple offers the most powerful and comprehensive environment for exploring and visualizing and solving even the most difficult math problems. Maple is especially good for anyone working with advanced math, including educators and students in upper year courses and math-heavy programs. The next product that I showed is Maple Learn. Maple Learn is an interactive online environment for exploring mathematical concepts, solving problems, and creating and sharing interactive content. It's especially good for math courses in high school, 2-year and technical colleges. It's good for first-year math courses and math courses for non-math majors in universities, and courses that make use of calculations such as economics, business, and physics. I also showed Maple Flow. And Maple Flow is a tool that makes it easy for engineers to brainstorm, develop, and document their design calculation. It's especially good for engineering students and instructors at any level who want to do design calculations. And you saw the Maple Calculator. So the Maple Calculator is a free all-in-one calculator that lets you solve problems, check homework, and explore graphs on your phone. And it's good for students from high school and up. And Maple Learn users who want to enter problems can do so on their phone's camera. And then as you saw in some of the videos, they're able to just have those results, solutions, handwritten solutions available to use. So depending on the needs of the students in your class and at your institution, it could be that 1, 2, or all 4 of the products in the Maple Mathematics Suite might be suitable for you. Regardless of what you choose, I promise that the products I showcased in this webinar will help your students understand and succeed and give you greater returns on the time and effort you put into teaching. So if you have any questions about any of the products I showed or need help deciding which product is right for you, I encourage you to contact us. You can go to our website, www.maplesoft.com/suite, and then you can get in touch with us. And I'm going to conclude with this last slide. So if there's math involved, we can help. The tools that I presented in the Maplesoft Mathematics Suite are available to you. And again, if you have questions, please contact us. So at this point, I'm going to see if there's any questions. And I know Nadia has been responding to some of them that have come in. Nadia, is there anything that you wanted to
share? I left a few questions for you, actually, Karishma. If you check on the list, the first one should be great for you to answer.
Sure. So the first question, it says, it seems as an international problem that we really need to motivate students to learn math. What has happened since they don't just want to learn, they want a result as easy as possible, if possible, effortless. And I agree with you. And so one of the things that we've tried to do, and some of the things I've tried to show you with the content, is to find ways to get them to realize that math matters, to motivate them, to have fun ways to engage with the content. I'm not saying this is an easy problem to solve, but what we want to do with our suite of products is to support you in that endeavor. And if there's ever any ideas that you have, that you want to create and need some help with it, we're here to support you with that. So the next question, is there a way I can get practice sheets like factoring? So yes, absolutely. So we have them in Maple Learn. We also have them in Maple. And Jonathan, I can send that to you after this webinar. So the next question over here that I have is, can Maple work with internet so that all can hook up in groups of a few and a teacher can follow up on them? So Maple Learn is our online product over here, and it can be used for students to kind of work together collaboratively. They can click there's a little share icon, and students can use it to share the document back and forth and to be able to kind of work on a particular concept. So Maple is our desktop product, and so it does have access though to the Maple Cloud. So what a student could do is work on a particular document, upload it to the Maple Cloud. Other students could go ahead and see that document. There could be groups, and then they can, with Maple, download it, bring it back into Maple, and continue to work. And if you're ever interested in learning more about Maple and the Maple Cloud and how that works, or even Maple Learn, I'm happy to do a demonstration for you. So is there a collaborative mode between students if there is a project? So right now, the collaboration you can have in Maple through the Maple Cloud, you can have groups. So there is no way at the moment for students to work together on a single file, but it is very easy for them to share the document and upload changes to their document, both in Maple and Maple Learn. And collaboration is something that is on the roadmap. The tools that are in the Maple Mathematics Suite or the Maplesoft Mathematics Suite, there's 4 tools. And so while Maple 2023 is definitely one of those tools, for some of the other ones, you would have to contact us and work with the account manager for your region, and then they can help you figure out which product is right and talk to you about how you can make it accessible to instructors and students at the school. So the next question I have is, can Maple be used for solving descriptive questions, for example, questions on related rates, optimization, finding tangent, and normal lines? Yes, it can. And we have some examples both in the math apps that you can do, as well as in the application gallery. And can we create practice worksheets for the class by Maple? Yes, that is something that you can do. So all of the things that I can show you, you can continue to work on them in Maple. You can deploy them to Maple Learn. All of our products work together. And so if there's something you want to see in more detail, please contact us. And Nadia, myself, or any of the staff at Maplesoft would be happy to show you. So Nadia, I think we covered all of the different questions. Is there anything else that you wanted to add?
No, I think you've done a a really good job actually, Karishma, to cover actually all the feature and capabilities that are available within the Mat Suite at Maplesoft. And just to let you know, a lot of people said that they were excited actually to have access to all those features and give it a try. So it was my last word.
That's fantastic. I am thrilled. This is something that's close to my heart and that all of us at Maplesoft are really excited about. If there are no further questions, then I'll give everybody, another 10 minutes. But of course, if you think of something at a later date, please feel free to get in touch with us. You can email us at info@maplesoft.com. And with that, thank you very much for joining this webinar and have a wonderful day.